Hello, hello. Can you hear me fine? Yes, I guess you can. Welcome, everybody. I'm glad to be speaking today about a cool experience we've had with a number of people about the registration system. As you know, Devoxx is put together by a number of folks that are passionate about what they do, and they try new things every year. And last year, we tried some of the things, and it really worked pretty well. Worked so well that we tried to take it to the next level and to bring this to the Google I/O conference. So this is what I will be covering today, together with Alex, who will tell you more about what he did this year to improve over last year. I'm Alexis Moussine-Pouchkine. I work at Google in the developer relations team, and let's start. So this is us. Not that many people in the room today, to be honest. This is a huge room, by the way. But this is 3,500 developers attending Devoxx every year. And for a number of years, we've had NFC-enabled badges. And that allows for a number of interesting experiences. And they're not just badges, as you know, they're wristbands. And for a number of years, Google has been helping the conference and supporting it by providing phones and tablets so we can register people, so that sponsors can scan you as you speak to them, that type of thing. Turns out, last year, I just couldn't find any phones or tablets to land. You know, it's this stupid thing. You ask around in a company and nobody is willing, or there aren't any available. So what do you do? So, and Stefan is like, come on, you've got to find your solution, right? This is Google. There are plenty of things that you can do to help us. So what I thought I could do is actually land a number of Chromebooks, namely Pixels, which are the device you have right here, which is a touch device. I'll get to that point in a second. But is also a Chromebook. So if you don't know what Chromebooks are, they're really very low maintenance devices. So you log in and any configuration you have in terms of data, application, everything comes up, although you've never been logged into that specific machine. So last year, if you had problems, and I hope you didn't, but if you did, probably you went and talked to Alex and he fixed whatever problem you had with your wristband, with a number of Chromebooks that were sitting by the registration desk. To get to that point, a colleague of mine, François Beaufort, who couldn't be with us today, unfortunately, with the help of another engineer at Google, wrote this library to be able to deal with NFC readers, which you hook up to this machine. This was built on top of the USB library. It was built entirely in JavaScript, so there's no native code. There's nothing to install explicitly on those machines. And this library has been fully open sourced. So that was the first quick win in terms of, you know, we do something, it works at the conference, and people can build on top of that. And Alex will tell you more about where it is now. So now let's move to Google I/O San Francisco. This is not quite 10 times as big as Devoxx, but it's still pretty big. The challenge there is to get 6,000 attendees flowing through the on-site registration. So the moment we open the doors, there's people walking in, they're checking in. I'll tell you more about the flow, and you need to be able to make this whole experience very fluid because people want to get to the keynote. I mean, there are a number of things that really make it useful for the whole thing to really work well. And you also want to deal with problems. There are always problems. There are always broken NFC badges, people that can't find their or one of their names fixed, or all sorts of issues. We had a number of people helping with the staff, and these people are wonderful people, but they've never used Chromebooks or that specific app before. They've never seen it. I had 20 minutes to brief these people, about 50 people of them, on the general flow, on how to use the app, what are the problems they may face. So that was another challenge we had to. So very. You know, from a very high level, we have a backend. The backend is not something we touched. It provides us with a REST API. It's in-house, I mean, on-premise. You have a bunch of Chromebooks, all with scanners attached, and the whole thing is on a private network. So that's how we had the setup at Google I/O this year. One thing I'll talk about is that every Chromebook has what we call, and was set up to use, a kiosk mode, which means the only thing you can do is run this one app. There's no escaping and starting a browser and going to a random website. The only thing you can do is this. You can bring up any developer tools or features, or you can basically just reboot and restart the app. That's all you can do. Let's see. The flow looked like this. This is different from Devoxx. People are all registered. There's no on-site registration. You can't just walk up and hope to get a ticket I/O. It was all sold out very quickly. But the first thing is you walk into the big venue and you go to one of the self-registration, self-check-in machines, and you say, this is my confirmation number, which basically says, I'm in the venue. Please prepare my badge. I'm about to come to counter whatever. So I type my name in, and I'm told to go to counter, MN, which is my last name. Then the second step is to actually go and pick up my badge and T-shirts and whatever I'm given. And badges are printed ahead of time. So we had 45 Chromebooks spread over self-registration, where, again, nobody's there. People are just scanning their QR code or typing in their email address. There was a help desk, and you could actually bring kids to the conference. So that was a very different and separate way of registering people. In terms of setup, the machines and the application that was written had an initial administrative screen where you could decide what this particular machine would do. Was it dedicated to the self-check-in, to the actual management check-in where you give away the actual badge, to gear pickup, which is one of the nice things you get at I/O when you attend, is you get some sort of goodies, an Android Wear watch this year, and badge programmer is for everything else, fixing problems. So you assign each machine to one of these roles. And then the check-in process is people walk in, they provide ID, we check who they are, and we give them the badge. We scan the badge, which means their name is taken off. I mean, they're set to having checked in, and they're removed from the list of people that showed up in the venue, and their badge was given to them along with everything else. The help desk this year was mostly for, problems we had with NFC tags. In a batch of thousands, there are a number of them that are dead on arrival. There's not much you can do about this. So you had to fix those. Some people had their names misspelled, so they insisted on having something reprinted. And people can't really read, but more on that later. That proved to be the biggest reason why we had people at the help desk. And so we did have to reprint a number of badges and reprogram them. So every badge has an anonymous but unique NFC identifier. So the whole app and all parts of the app are actually written in their Chrome apps. So Chrome apps, or you might hear Chrome packaged apps, are really just web apps. They're packaged in a certain way, and that have additional features in how they can access the hardware, namely the USB port, so we can talk to the NFC reader in particular. So they're immersive. They have full screen capabilities, for example. There's no way out of it, especially in the kiosk mode. You build them using HTML5, CSS3, any library, MVC library you want, or no library. Hopefully you'll use Polymer or something modern as things go. And you develop those with typical developer tools for web development. So things like Chrome DevTools is, for example, a very good tool to do live editing. So save, reload, and as you go. They're secured by default. There's a content security policy by default. That's very important. And there's no ability to use eval or functions and no inline scripting either. All the scripting needs to live in its own dedicated JavaScript file. Offline by default, that's also important. All the assets are local, and there's an API to talk and reach those assets. You can use the Chrome APIs, and that's what I meant by accessing, for example, the NFC library. You can access power, system, socket, Bluetooth, all these features. And finally, they're distributed, packaged and distributed, optionally through the web store or through your own mechanism. But the web store, the Chrome Web Store, is one way to distribute those. And that's typically what we did. So we only pushed this out once, and it was propagated to every Chromebook in which I was logged in with this given user that had this app configured. And I'll more on that in a second. So a Chrome app really is just a web app which has a manifest, which gives it a name, a version, and an entry point. So a main.js file, for example. The second part is the actual main.js that has a number of uses of the window API, for example. So you can create a window, and in that window you have some HTML code, and this is where you actually have the content. So window.html is finally where your application lives. And there, again, you can use any technology you want. We didn't use any framework in particular, or François did not. But the best is probably that I show you a demo. So before I do the demo, I need to simulate what it kind of looks like. So first of all, here's the live demo. This is typically what people had in on their screens while people were doing their self-check-in. So people are waiting with badges, T-shirts, and everything, and they're pulling out names as they see those names show up here. Oops, sorry. So let me simulate people when we open the doors, 7 o'clock in the morning, something like that. So typically we have people that start showing up, we refresh these, and the type of things you can see here are the fact that quickly there's a lot of people, so you could start scrolling. Typically, you can start filtering by name. So by some time, you want to see if you're sitting at counter AB, you want to see only those people on AB. And there's only one person at this point. You can remove people because they've checked in, but clearly they didn't show up within an hour, and they're still on the top of the list, so you can decide to remove a few people here or bring them back. So it's pretty basic, but it gets the job done. And then you can do things like, obviously, when the person actually shows up, bring up their name, give them what you need to give them, scan, and when you scan, typically, they're marked as having received everything, and as you escape, they disappear from the list. So it's pretty basic, but it's scaled pretty well. So as you can see, this is really from a few minutes after we opened the doors. This is pretty much what we had seen. This is all dummy data, by the way. So don't look into this. There's some interesting data. So that's pretty much the demo at this point that I wanted to give you. And this was all running on, again, Chromebooks, which I'll get to that in a moment. So I'm seeing the exact same thing here, by the way. Are touch devices, and that has proven to be a very interesting capability that was used by many more people than we had initially thought. So let me remove that if I can. Nope. And get back to the slides. And here we go. So as I said, this is an interesting form factor, Chromebooks in general. It has, first of all, a touch screen. And as we were looking at those 50 people that were helping, they were all using the screen. They're just used to that. Most of them were in their 20s. Maybe it's a matter of generation, but nobody was fiddling trying to find the mouse or the trackpad. It's so much easier to actually point to the right person. So that's one thing. The second thing is that it has a keyboard. If you need to search for somebody, it has a physical keyboard, and you can do escapes, you can type in quickly. That also proved to be very interesting. If you especially need to type in and fix somebody's spelling, again, that is compared to typically to tablets or phones, it's probably much easier to use. And it also has a built-in webcams. So if you want to scan a QR code, for example, you can do that as well. And you don't need to like try to place the camera of the phone or the tablet in front. It's right there sitting. So you just present it there and you've checked in. And that's really how fast people were checking in at the conference. Again, there's this kiosk mode. So for the Chromebook, you define what the app should be. So you install it once, and then you should say, this is the only thing that I can run. No web console, developer console, no browser. The JavaScript console is disabled. There's no access to the code itself. So you can't do like a view source. That also is forbidden by the kiosk mode. So that proved to be pretty nice as well. At least our security people were happy when they did the review. The other thing I was happy about was continuous deployment. And in this case, this was continuous deployment to quote-unquote production, and in this case, desktops. So if you've ever had to deploy software to desktops, you know how painful that can be. We actually had to accommodate for a number of important changes. Things like we had not anticipated the fact that people could come back and say, the watch I got, I want the other one actually. I want the other model. For us, it was like, the UI didn't anticipate that. If they were given a watch, that's it. They couldn't come back. So we were asked to change that, and that wasn't that hard to do. There were things like when people checked in, they're like presenting the QR code. It says, yes, I recognize you. Please go to counter AB or to Sandbox or to speakers or whatever counters we had. Turns out people don't read this. They're like, okay, you're checked in. Where do I go now? And they never went to the right counter. And so they were told, I'm sorry, I can't find your badge. So they ended up in the help desk for no reason, just because they couldn't read what it said. So we made one more change, which was to make the counter name like this big and bold and red or whatever we used. So a number of changes, and making any change was easy as editing, committing this typically, and asking the people to reboot the Chromebook. And rebooting the Chromebook and restarting the app is about 10 seconds. So there was actually an icon that started blinking when an update was available. We had pushed something, and people were taught how to do this. And it was really a matter of 10 seconds before they were up with the update. And we did about 12 deployments in 2 days, averaging for about for a total of 30 commits, changes that we had to do. So I think we were pretty agile in the way we developed this, and really wasn't a problem at all. Finally, Chromebooks. I mean, there are a lot of nice things to say about it. The thing I like very much about it, also beyond the fast boot that I mentioned, is the encrypted local data. So if somebody steals it, there's not much they can do with it. It's easy to wipe. So when you want to repurpose this, it doesn't have data from the previous use of the previous application. And as you probably know, they're quite affordable. And even if you're looking for touch devices, I think the latest Acer Chromebook comes for less than $300. So maybe a bit more, something around 300 euros. So for me, as far as I'm concerned, this is the ultimate device for a kiosk, and specifically registration desk. So just like Devoxx, for organizers, life after a conference like I/O restarts a few weeks after the conference, not a few days or hours. We need to recover. So part of the things I did was re-implement the backend. Remember, this was a black box. There was a REST API. So I re-implemented this on top of App Engine using something called Cloud Endpoints, which has the interesting benefit of having complete OAuth integration. So this was nice to have, and it generates the JavaScript client for you. So you just make function calls from JavaScript. There's no constructing the request and doing all of that. This is done for you. The test script that allowed me to do the demo a second ago were really just the dummy data that I had generated. We had ran a number of tests before, obviously, Google I/O, and I just repurposed these. And so hopefully all of this will be open source, both the client, which you saw, and the backend, so you can be inspired by this, look at it, and maybe reuse it, but most likely be inspired and see how it's built, because it's really not that hard. So hopefully we'll be able to open source this all really quickly. And now hand it over to close this to Alex, who's going to tell you more about how he built on top of all the things and what he did this year.
Yeah, so every year we have to beg for the partners to get us some new devices because Devoxx don't own those devices. So this year we got the Chromebooks, like 30 of them from Google. So thank you.
And different kinds of Chromebooks.
And different types, like the HPs and the Pixels, of course. But the HPs are really more practical for us because our main concern was distributing them to the partners for the scanning. So they are really small and they are tucked away behind the desk. So they only have the scanner. So you just have to tap your wristband to the scanner. It beeps. So that's important to have the beep. And then they're all set to go. And then
the beep is important. I mean,
yes, the beep is really important. You will hear it in the venue a lot of times. Beep, beep, beep. So that's good because when that's not beeping, you know that there is a problem. But during the day, we actually do not have any crashes, no problems whatsoever. So that's very good for the first day of deployment. So probably I will not need those 30 commits to do. I will
not 30
do
commits.
None of them. So also the cool part was the deployment. So we have one login. You log into the system, it downloads the app, and you're up and running. So how it's built? Because we're crazy geeks. We wanted to use the latest technology, so we tried to why not make the UI, although not that pretty in Polymer, but we were really happy to make it running like a production app. Although the technology is still in beta, it runs perfectly. So we have two parts, like the help desk, like that we had last year as well. So for helping people that had problems with NFC phone scanners, they could come by me, and I can log into the database. Therefore, a Chromebook is also handy, searching for something, and then we can program the wristband there. But the main part was this year for distributing into the partners. The main focus was actually continue the Chrome NFC library because we had another different scanner type. So like the first iteration of the Chrome NFC library was really conference driven. So making it only support the two types and was a bit messy. So we re-architectured it. So it was easier to add extra NFC readers and hopefully some more.
If you think NFC is a standard, you're in for a big surprise, both in terms of readers and tags.
Certainly readers, that's a hell. So it's the speaking through a lot of layers, and that's why we had to rip it out a bit to layer it nicely. Also here everything is done in the open source, so you can get every commit there. I'll have here, the purpose was also to make it easy to use, because we dump it back to the community. We hope that it's getting used. So this is actually really a piece of the code for writing the wristband. So we wait for a tag to touch the device. As soon as it is, we make the tag like if you scan with your Android phone your wristband, there is the URL to the Play Store for the Beacon game that everybody hopefully is playing. So you can download it from the Play Store. And some data. Hopefully a later iteration of the library will be even more nicer, but at least it's not a lot of code. So this is enough to write a tag now. So life after Devoxx. So I will be continuing writing on the NFC library. I hope that the Chrome NFC repository will pick it back up, so it will get used at Google I/O next year. Due to the USB library that's used in Chrome, it's only a very thin layer. I hope that I can make it work in Node.js, so only rip out the USB part, so we can have sorry to hear, to tell it, but without Chromebooks, so working on another device. And the polymer, make the examples, making Polymer a nice app, because like there's a very cool app on Android that's called Tag Info that have all the tag information from a tag. I hope to contribute that as well, so you can have the complete tag layouts of everything. So and of course more NFC feature, because the current NFC library is really conference driven, and it does all the things we need at a conference. So
I probably need to take that out.
So
great. So I think we're pretty happy with where we are today, but there's always better things to do. We're also very interested in getting information on, how is it working for you as a user? How would you make it better? So certainly if you have comments or questions about it, we'd be more than welcome to take those. And thank you, Alex, for all the work you've done so far.
Thank you.
Thanks for attending this. We probably have a few minutes for questions, or you can come to us. We'll stick around for that. Thanks for coming.